Hi, let's start learning the next basic part of programming, loops. When you write programs, quite often you need to repeat certain actions. In other words, loop them. For example, you need to print the word hello on the screen 10 times. You can write a command that prints this word and copies this string 9 times. But what if the task is such that you need to print 100 times? In this case, you'll get tired of copying the string. Also imagine that the user needs to enter a number and you need to print all the numbers from 0 to this number. How will you do this with the tools you learned? You can use an if statement with the condition if the user entered the number 2 and print the numbers 0, 1 and 2. But for every possible number, you won't write the required number of if statements. My point is that in programming, we need tools to repeat commands. Up until now, our commands have been executed from top to bottom. Even with conditional operators like if, switch and ternary, we still move from top to bottom. And in order to repeat some action, we need to go back. For this, we can use loops. A loop is a place where commands are repeated while some condition is true. There are 3 loops in C++, while, do while and for. They can all be used to repeat actions, but they're slightly different from each other. In these 3 lessons, I'll talk about each of them. And I'll start with the while loop. Let's move on to the syntax of using the while loop. It's quite simple and almost identical to the if statement. Only instead of the word if, you write while. This loop works in the following way. The program reaches this construction and checks whether the condition is in brackets is true. If yes, then the statement inside loop is executed. But unlike the if statement, the program returns to the condition again and checks it again. And if it's true again, then the statement inside the loop is executed again. And so, this loop will repeat until the condition becomes false. If the condition is false, the program exits the loop and executes the following commands below. It may be that the condition is false at the first check. In this case, the statement won't be executed even once. This is how easy it is to loop one or more commands. Note that the while loop needs one statement. Therefore, if you want to put several statements in a loop, you can use curly brackets. Below, I've written 5 examples of using our loop. Let's look at the first one. I've commented out all the others for now. I've also put each example in additional curly brackets. You don't have to do this. I did this for convenience so that I could quickly collapse and expand the code. Empty curly brackets have a certain meaning and are called scope. I will write a separate lesson about this. So, in the example, we see that there is a loop, the condition of which will always be true, because it contains the literal true. Therefore, our commands to display text on the screen will be executed forever. Let's run it and look at the output. There is little sense in such a loop, because usually a condition for exiting the loop is needed. Such infinite loops are sometimes encountered in programming, but only when the loop body itself has a construction that will pull the program out of it. For example, the word break, which will be discussed in a separate lesson, or the word return, which we'll discuss in the lesson about functions. Let's uncomment the second example. It's already more interesting and makes some sense. In it, the computer guesses the number 50 and the user has an infinite number of attempts to guess this number. First, I create 2 variables. The first one is responsible for the computer's number. I decided that it will be the number 50. The second one is for the number that the user enters. Then I ask him to enter a number from 0 to 100. This is a hint to make it easier for the user. Then he enters this number and we reach the loop. Please note that I'm currently using the code mono font, which has a thing called ligatures. These are shortened combinations of certain symbols. For example, here I have an exclamation mark and an equal sign. I can even put a space between them and you'll see them. But when they are written together, the font uses a ligature that changes 2 symbols into one, more understandable to you from math lessons. So sometimes you'll see other ligatures in my lessons. It's all because of the font. So In the loop, there is a condition while the user's number is not equal to the computer's number. If it's true, we enter the loop body. In it, we say that the user made a mistake and let him enter the number again. And so it will repeat until the user enters the number 50, after which we'll see the congratulatory text. The user can enter the number 50 the first time, then the commands in the loop won't be executed from the very beginning. Let's run the program and see how it behaves. Let's move on to the next example. Here, the program asks the user to enter a positive number, and he will enter the number until he enters a positive one. That is, we wrote a check for the correctness of the number. In the loop, the condition is while the number is less than or equal to 0. In other words, while the number is not positive. Inside, we tell him about his mistake and let him enter it again. At the end, we thank him for the correct entry. Let's run the program and see how it behaves. Let's move on to the next example. In it, we have the task of displaying integers from 1 to 10. First, I create a number variable, which I assign 1 to. Then, I write a loop with the condition while the number is less than or equal to 10. Inside the loop, I display the number and use a postfix increment. Let me remind you how it works. First, it gives us the value of the variable, then it increases it. It turns out that during the first iteration is the execution of commands in the loop, we will display one on the screen. Then the variable will increase by 1 and become 2. Then the condition is checked again, and since 2 is less than 10, the command is executed again, but this time we see 2 after 1. And so the increase by 1 is repeated until the variable becomes 11. Then the loop will finish its work. Let's run the program, look at the output. Let's move on to the next example. In it, I wrote a simple calculator. I create a variable that is responsible for an operation in the calculator. This can be addition, multiplication, division, and subtraction. Let's look at the loop. In it, we wrote until the variable is equal to the letter Q. Why this letter? The thing is that below we ask the user to enter the operation symbol. If he wants to exit the program, he will enter the letter Q, and the loop will stop. Therefore, we can interpret the condition of our loop as until the user wants to exit the program. We can't check the value of an uninitialized variable. So I set it to an initial value that is different from letter Q. Because of this, the condition will be true the first time we enter the loop. Then, in the loop, I create 3 variables. All variables that you create in a loop are destroyed after the program exits it. My variables are responsible for 2 numbers that the user enters and for the result of the operation. Next, I ask the user to enter these 2 numbers, and he enters them. After that, I ask him to enter the operation symbol, and I always tell him what he should enter. Then he enters the symbol, and I check it in switch. Know that you can put both if and switch, as well as other loops in loops. So if the user entered the plus symbol, we write the sum of the 2 numbers in the result variable, and we display this expression on the screen. If he enters the minus symbol, then we write the result of subtracting the numbers, and so on. If the user enters the letter Q, then we say goodbye to him. In the case of other symbols, we say that he entered something incomprehensible. Know that when dividing, we check whether he entered 0 in the second number. You can't divide by 0, so we tell him about it. No matter what he entered, we return to the loop condition. If it's true, we repeat all the actions again. And so on until he wants to exit the program. Let's run this program. I'll enter some numbers, perform some operations, and exit the program. And let's move on to the last example, where I want to output a rectangle of stars. There will be 5 rows and 3 columns. How can we output a rectangle to the screen? We can write a loop that outputs 1 row. More precisely, it outputs a star symbol to the screen 3 times. Here it is. I have a variable that is responsible for the star number. After each star is output, it increases by 1. After this loop is finished, we will output 1 row. Therefore, we put this loop into another loop that is responsible for the number of such rows. We have 5 of them, so we also have a variable that is responsible for the row number. And when the row is completely output to the screen, this variable increases by 1. Let's run the program and look at the output. You can play with the numbers here and here to see how the output changes. In fact, in the last example, it's better to use the for loop, and in the calculator, the do while loop. You will understand why in the following lessons. The main thing now is to understand how the while loop works. And that's the end of this lesson. Thank you for watching. I hope I helped you a bit. If you enjoyed this video, you can support me by liking this video, writing a comment under it, subscribing on the channel, becoming a sponsor of my channel to grant access to practice lessons, or donating me through the link in the video's description. All these things popularize my channel and motivate me to record more lessons for you. Goodbye.